Welcome to the Clinical Capsule, your trusted guide for clear and concise medical learning.
So I want you to imagine you're sitting on that crinkly paper on the exam table. You know the one.
Oh, yeah. I mean, we all know that exact sound.
Right. And your doctor walks in, says hello, and then immediately just sits down to stare at a computer screen.
Which is pretty much the universal medical experience these days.
Exactly. I mean, think about it. In, say, 1950, that same doctor would have relied on maybe a couple of textbooks, a stethoscope, and basically whatever you could tell them.
Yeah, the tools were quite literally in their little black bag.
But today, that screen they're staring at holds your lab results, imaging scans, and potentially millions of genetic data points about your family history, or even the bacteria in your gut.
It's a massive amount of data.
It really is.
Yeah.
And as patients, we kind of expect a diagnosis to be this simple exercise in engineering. Like, you break an arm, the x-ray shows a jagged white line, and boom, it gets fixed.
Right, the broken machine gets a new part.
But stepping into the modern diagnostic landscape reveals this environment that is just incredibly complex. It's constantly shifting, and honestly, it's deeply overwhelming.
Well, yeah, because it is the ultimate collision of an ancient art and this massive modern data explosion.
Right.
I mean, the sheer volume of information a physician has to process today is completely unprecedented. Yet, the person sitting on that crinkly paper still requires the exact same human connection they did a century ago.
And that tension right there, that's our mission today. We are taking a deep dive into the modern practice of medicine.
It's such a fascinating topic.
It really is. To understand what actually happens behind the stethoscope, we're exploring a stack of foundational medical texts. So we've got excerpts from definitive textbooks outlining the philosophy of patient care. We have detailed breakdowns of the genomic revolution, and this really fascinating analysis of how doctors are totally rethinking disease prevention.
Yeah, the concept of prevention has completely changed.
Right, because ultimately we want to know how a human brain processes a literal tsunami of biological data without missing the simple fact that the patient sitting in front of them is, just terrified. Okay, let's unpack this.
Let's do it. So the historical baseline for this tension, it's captured beautifully in this quote I love from the 1950 edition of Harrison's Principles of Internal Medicine.
Oh, yeah, the classic textbook.
Exactly. The authors wrote that the patient is no mere collection of symptoms, signs, disordered functions, damaged organs, and disturbed emotions. The patient is human, fearful, and hopeful, seeking relief, help, and reassurance.
I find that so striking because it emphasizes that having all the sophisticated lab technology in the world doesn't automatically make you a good physician.
No, not at all.
There's this absolute necessity for the art of medicine, right?
Mm-hmm.
Intuition, the experience, the actual human judgment.
Right, the art has to balance out the science.
But I have to ask, push back on this a little. If a modern hospital has AI that can scan millions of genetic markers in a second and, cross-reference them against every medical journal on Earth, why are we still relying on human intuition?
Well, that's a fair question.
Isn't the traditional physical exam where the doctor just listens to your chest or pokes your abdomen, isn't that becoming fundamentally obsolete? Why not just run all the tests and let the computer sort it out?
Because honestly, running all the tests is actually one of the most dangerous things a modern doctor can do.
Wait, really? Dangerous?
Absolutely. Because when you just expand the number of tests you order, you exponentially increase the likelihood of discovering what we call an incidental finding.
Oh, okay. What does that mean in practice?
Well, let's say a patient comes in with just a persistent cough, and the doctor decides to skip the basic exam and just orders a massive high-resolution scan of the entire chest and abdomen.
Just going straight for the heavy artillery.
Right. So the scan might show that the cough is just from a mild resolving infection, which is fine.
Mm-hmm.
But it also reveals this tiny, bizarre shadow on the patient's kidney.
A shadow that has absolutely nothing to do with the cough.
Precisely. That shadow is an incidental finding. So now the doctor has a huge dilemma.
I can see that.
Right, because is this a crucial clue to a silent, early-stage cancer? Or is it just a red herring? Like a harmless cyst the patient has had since they were born that will literally never cause them a moment of pain.
So being a good doctor isn't just about having the biggest database of medical knowledge in your head. It's about being a detective who knows when not to chase a lead.
Exactly. Because if you unleash the full power of modern diagnostics on that red herring, you might subject the patient to unnecessary, terrifying, and actually physically risky biopsies.
Wow. Yeah, you could do more harm than good.
The art of medicine isn't just about knowing what to do. It's really about having the clinical judgment to know when to hold back. Weighing whether a test is riskier than the disease itself is a calculation a skilled clinician makes a dozen times a day.
Okay, I see the distinction now. So the physical exam and the history taking, they aren't just about hunting for raw data. They actually provide the context you need to interpret the data.
Yes, context is everything.
When the text talks about a doctor taking a patient's history, it notes that any event, no matter how trivial, might be the key. A doctor isn't just making a list of symptoms, right?
No. Yeah.
They're like listening to the inflection of your voice, they're reading your facial expressions and observing your body language to figure out what actually matters.
Yeah, and a deeply experienced clinician can often formulate a really accurate differential diagnosis just by listening to the patient tell the story of their illness.
That's amazing, just from the story.
Right. And then the physical exam just searches for objective indications to confirm that educated guess. But the textbook makes a really crucial point here. Detecting a faint heart murmur isn't about having keener ears than a computer.
Right.
It's about having a mind that is alert to those specific findings based on the conversation that just happened. You have to know what you were looking for to actually see it.
Which brings a massive challenge into focus, I think, because what doctors are looking for today has expanded way beyond human comprehension.
Oh, completely.
The texts detail this radical shift from simple history taking into what they call the era of omics. And they don't just mean genetics, right?
No, what's fascinating here is that genomics was really merely the opening chapter.
Okay.
I mean, when the human genome was fully sequenced back in 2003, there was this assumption that we'd finally have the master blueprint for all human disease.
Like we finally found the instruction manual.
Exactly.
Yeah.
But we quickly realized that our phenotypes, basically how we actually look, function, and fall ill, they aren't determined by our genetic hardware alone. And that realization spawned epigenetics.
Epigenetics. Break that down for me.
So it's the study of how gene expression is regulated. You could think of it as the software that tells the genetic hardware when to turn certain genes on or off.
Okay, so what actually triggers that software to turn a healthy gene off and a disease gene on?
Well, that is where exposomics comes in.
Exposomics. That's a new one for me.
It's incredible. It studies how environmental exposures impact our health at a literal cellular level. So it measures how smoking, sunlight, diet, exercise, and even really abstract factors
Like what?
like chronic stress, education levels, or neighborhood violence. It measures how those things physically alter your epigenetic markers.
That's wild. So your environment actively rewires how your DNA operates.
Exactly. Your life experiences are basically writing the code for your genes in real time.
Okay, so here's where it gets really interesting for me. The statistic from the sources that completely reframes this entire concept is the sheer scale of the human microbiome.
Oh, yes. Microbiomics.
Right. So the human genome, the DNA we inherit from our parents, it contains about 23,000 genes. But the microbes living on our skin, in our mouths, and mostly in our gut, or microbiome, they contain 3 to 4 million genes.
It's staggering when you think about it.
Millions. So those millions of foreign genes are constantly interacting with our own cells, right?
Oh, constantly. They play a massive role in maturing our immune system, regulating our metabolic balance, and even determining if we're susceptible to autoimmune diseases.
Wow.
They're literally metabolizing our food and producing chemicals that travel through our bloodstream, directly influencing our epigenetic software.
Okay, so to visualize this, we really have to abandon that old metaphor of the body as a machine. Like, historically, a doctor acted like a mechanic. You have a broken carburetor, you swap it out.
Right, very straightforward.
But in the omics era, treating a patient is more like managing an incredibly dense, bustling city ecosystem.
That's a perfect analogy.
You can't just patch a pothole on Main Street without understanding how it affects the traffic patterns, the local businesses, the weather, and, the 3 million microbial citizens who live there.
Exactly. And managing that sprawling metropolis of data is the defining burden of the modern physician.
I can't even imagine.
The text actually provides a fascinating visual contrast here. It references Johannes de Catham's Fasciculus Medicinae from 1491.
The really old medical text, right?
Yeah, the first illustrated medical text ever printed. It has these woodcuts of Renaissance doctors consulting a few ancient books to diagnose a patient.
Right.
But today, a doctor consults the internet, continuously updating clinical guidelines and literal millions of genetic and microbial data points for just one single patient.
I mean, when you log into your patient portal and see 50 different test results you don't even understand, imagine your doctor trying to stitch all of those into a cohesive narrative. How does a human being actually manage that city ecosystem without losing their mind?
Well, the reality is that a single human being can't. They just can't.
Yeah, that makes sense.
The texts explain that the practice of medicine has undergone this massive structural shift to cope with the complexity. We have firmly entered the era of team-based care and electronic medical records, or EMRs.
So the whole Marcus Welby MD thing is over.
Completely. The days of the solitary primary care doctor doing absolutely everything you know, delivering your baby, managing your heart condition, treating your pneumonia, those days are largely gone.
I mean, as a patient, that fragmentation is incredibly frustrating. If I have multiple chronic issues, am I just getting bounced around like a hot potato among a dozen specialists?
It definitely feels that way sometimes, and the sources acknowledge that exact frustration.
Right, because I might see an endocrinologist, a cardiologist, and a rheumatologist. It feels like being bounced around among different mechanics working on the same car, but nobody's talking to each other. Who is actually the mayor of this city ecosystem?
Well, because the burden of disease has shifted so heavily toward chronic illnesses,
Yeah.
care has just had to become highly specialized. Even the hospital environment has differentiated.
How so?
If you're admitted to the hospital today, your regular primary care doctor is likely not the one checking on you. You'll be seen by hospitalists. These are board-certified internists who work exclusively in the inpatient setting.
Oh, I've heard of them.
Yeah, or you'll see intensivists who direct care solely in critical care units.
I mean, I get that they have the specific training for that high-stakes environment, but it creates a massive risk for miscommunication during the handoffs, doesn't it?
It absolutely does. The proposed solution to this fragmentation is the concept of the medical home.
The medical home, what does that look like?
It's a structural model designed to integrate team-based primary care with subspecialty care. In a functional medical home, it is the explicit duty of your principal physician to provide cohesive guidance, making sure the big picture of your health isn't lost.
Gotcha. And theoretically, the tool that allows the principal physician to track all of this is the electronic medical record, the EMR.
Exactly. EMRs are supposed to be the master blueprint of the city.
Right. They hold the labs, the scans, the notes from the cardiologist and the hospitalist. And I can clearly see the immediate benefits, like using barcoded tracking for medications instead of relying on a doctor's notoriously terrible handwriting that undeniably saves lives by reducing basic human error.
Oh, for sure. And they offer rapid access to historical data that used to be buried in paper files in a basement somewhere.
Right. But there's a downside, isn't there?
A huge one. The text highlights a deeply dangerous side effect of how EMRs are actually used in practice. You see, EMRs require an exhaustive amount of data entry.
Which takes forever.
Yes, and it's often driven more by administrative billing requirements than by actual clinical need. Physicians are under immense time pressure, so they frequently resort to cutting and pasting a patient's past notes into the daily record.
Wow. So the note from Tuesday just gets pasted into Wednesday's file to save like 15 minutes of typing.
Exactly. But doing that disrupts the narrative flow of the patient's illness.
Because it just looks the same.
Right. If a doctor is just skimming copied and pasted text, they might easily miss subtle, crucial changes in a patient's breathing or mental state over a 3-day period because the paragraphs look totally identical.
That is terrifying.
An EMR structures information in a way that can actually obscure the real-time story of what the patient is experiencing. The screen becomes a barrier, creating physical and emotional distance between the physician and the patient.
I see. So we can track a patient's decline perfectly in an EMR, analyzing every fluctuating enzyme and protein, but by the time a patient is in a hospital bed surrounded by intensivists, the EMR is largely just documenting the crash.
Sadly, yes. The data is often reacting to a crisis that has already happened.
And that's why the text argues that modern medicine has to shift its focus entirely, right? Away from the hospital bed, away from the EMR, and out into the patient's daily life.
Yes, this is the evolution of disease prevention.
Okay, let's get into that.
Historically, the success of a healthcare system was measured by extending lifespan, just keeping people from dying.
Right, quantity of years.
But today, the metric for a highly functioning system is extending health span. The preservation of a high quality of life, free from chronic disability for as long as possible.
That makes a lot of sense. The sources outline 4 specific tiers of prevention, and if we apply our city ecosystem metaphor to them, the progression makes perfect sense.
Yeah, let's walk through them.
Okay, so the first is tertiary prevention. This is rapid action to prevent imminent death in the setting of acute illness.
Like treating a massive heart attack as it is happening in the emergency room.
Right. So in our city, tertiary prevention is the ambulance arriving after the massive multi-car pileup on the highway. It's necessary, but it means the system has already failed.
Very true.
So then we move upstream to secondary prevention.
Secondary prevention focuses on avoiding the recurrence of disease in someone who is already affected. So a classic example is prescribing the drug tamoxifen for a woman who has been successfully treated for early-stage breast cancer.
To drastically reduce the risk of the cancer returning.
Exactly.
So this is putting up a reinforced guardrail at the site of the crash to make sure nobody else drives off that specific cliff. It's better, but the danger is still present.
Right. So moving further upstream, we have primary prevention.
And what does that look like?
This attempts to reduce the risk of incident disease among individuals who have a known risk factor but haven't developed the actual disease yet. So treating high blood pressure or elevated cholesterol with medication before the person ever suffers a stroke.
Okay. We are lowering the speed limit on the highway. We're actively managing the risk factors.
Yes. But the text introduces a concept from 1979 that represents the absolute ideal of medical practice, which is primordial prevention.
Primordial prevention.
It focuses on preventing the risk factors from even developing in the first place. It deals with those upstream determinants of health we discussed earlier in exposomics.
Like eating patterns, physical activity, environmental toxins.
Yes, and the social determinants of health, like education and economic stability.
I love this because primordial prevention isn't fixing potholes or lowering speed limits. It is the city planner designing a transit system where cars and pedestrians simply never intersect. The danger never even materializes.
That's a great way to put it. The visual concept the text uses for this is called squaring the curve, which refers to the compression of morbidity.
Squaring the curve. Can you explain that visually?
Sure. If you graph normative aging, health is a line that slowly slopes downward over decades. People spend years or even decades in a state of morbidity, living with chronic pain, mobility issues, managing multiple diseases before they finally pass away.
So instead of our health slowly draining away over 30 years like a leaky battery, the goal of primordial prevention is to keep our stock of health fully charged for as long as possible.
Exactly. You square the curve, you maximize the years of vibrant, healthy function, and then ideally experience a very steep, short decline right at the very end of life.
You compress the morbidity into a tiny window.
Maximizing health span is really the ultimate triumph of the science of medicine.
But the profound reality that every physician must face is that no amount of primordial prevention and no mastery of the human microbiome can stop mortality forever. I mean, eventually the battery dies, the line drops.
The city inevitably falls, and that inevitability brings the practice of medicine to a critical juncture.
There is a definitive moment in care where the science runs out of options and the ancient art of medicine must completely take over.
The shift from cure to care. The texts are deeply explicit about how a physician must handle this transition. When a grave prognosis is certain and terminal illness is inevitable, the guiding medical principle shifts to a Latin phrase, primum succurrere.
First, hasten to help. When you can no longer heal the physical disease, the focus must shift entirely to healing the person's experience of that disease.
Yes, and this requires a profound level of emotional intelligence, particularly regarding informed consent.
Which is more than just paperwork, right?
Oh, much more. True informed consent is not a bureaucratic exercise. It is not handing a terrified patient a clipboard with a dense legal form as they are being wheeled into the operating room.
Because a patient in that state, facing the end of their life, is dealing with a massive power imbalance. They have limited medical knowledge and are facing the ultimate unknown.
Right. Therefore, the text defines informed consent as an iterative, unthreatening conversation. It's a relationship built on trust, where the physician assesses the right tempo for sharing difficult information based on what the patient is actually emotionally prepared to absorb.
It's a repeated dialogue designed specifically to mitigate the patient's fear.
Exactly. Medical schools can teach a student how to read an EMR or interpret an epigenetic panel, but they cannot easily teach the integrity and compassion required for those conversations.
Which brings us to a quote from Francis W. Peabody. He delivered a lecture to Harvard Medical School students in October of 1925, and it really serves as the ultimate thesis for this entire deep dive.
It's a beautiful quote.
He told his students, "The secret of the care of the patient is in caring for the patient."
It is a profound distillation of the profession. Despite devoting chapters to the 3 million genes in our microbiome and the complexities of team-based care and the massive data infrastructure of modern hospitals, the text deliberately emphasize a remarkably analog intervention at the end of life.
The physical laying on of hands.
Yes. When a patient is dying in a modern intensive care unit surrounded by the air jets of ventilators, the relentless blinking lights of monitors, the intrusion of life-sustaining machinery, it is dangerously easy for the medical team to focus entirely on the physiological battle against the disease.
A battle they will ultimately lose.
Right, so the text reminds the physician to focus on the human being in the bed, to physically touch them, to comfort them, and to ensure their human dignity is maintained, rather than letting them die isolated among the machines.
So what does this all mean? For you, listening right now, this fundamentally changes how you should view your next encounter with the healthcare system.
It really should.
The next time you step into a clinic, you are walking into an intersection of ancient empathy and cutting-edge data science. You have every right to expect your physician to be a perpetual student of the science, someone who understands the omics, navigates the EMR, and actively works to maximize your health span.
But you also have the right to demand an active practitioner of humanity, someone who sees your entire life's ecosystem, not just a broken machine that needs a part swapped out.
Beautifully said. The physician has a mandate to strip away their own biases and utilize every ounce of available data to find what is best for you, whether that means deploying the latest targeted gene therapy or simply pulling up a chair to hold your hand and answer a terrifying question for the third time. Well, we have covered a massive amount of ground today, transitioning from 15th century woodcuts to the genomic revolution, and really unpacking the true meaning of health span. Thank you for joining us on this exploration of what it actually means to practice medicine.
And to close our deep dive today, I want to leave you with a final thought to ponder regarding the future of that practice.
Oh, absolutely. Let's hear it.
We discussed how dangerous the avalanche of data can be for a human brain. But artificial intelligence is getting exponentially better at the science of medicine.
Right.
In the near future, an AI might be able to synthesize those millions of data points from your EMR, your microbiome, and your environment to make a flawless, instantaneous diagnosis every single time.
It's definitely coming.
So if a computer takes over the science, does the physician's job become entirely focused on the art? If the machine can diagnose you perfectly, perhaps the doctor of the future will simply be a professional of empathy, dedicated entirely to guiding you through the human experience of healing.
Wow. It's a fascinating vision of the future, because even if an AI can read the scan perfectly and point to the anomaly every single time, we're still going to need someone sitting beside us on that crinkly paper, holding our hand and telling us what it actually means for our life.